Well, let's look at a new concept, deployment to a Docker container. This is similar to ships. You know, when ships have a cargo used to go loose in the hull, and if the cargo went wrong, the idea was that they should not harm the rest of the cargo, and said it would be grouped. Then we created containers with certain characteristics, and all transportation is done with containers on the basis of standard international measures. Even the ships transporting containers and the cranes on the docks, everything is standardized to manage that kind of container. Now, the idea here is to use containers to be able to deploy software. So the idea of using containers to package software applications started with Linux. It created containers. It was difficult to use, and they required very advanced functions. You had to be an expert in Linux. You had to know what functions to touch on the kernels and to use those containers. Now, Docker company created several services having access to the kernel and deploys them as an API. The abstraction level is much higher. It facilitates use and makes the use of container much more popular for apps. Let's see the main concepts. Docker is a product, it's a platform, but it's also the company's name, Docker Inc. Now, Docker Inc. created a platform called Docker that facilitates the development, deploy, and execution of applications using containers. Now, this platform provides a virtualization that makes that the app can execute in the container with all the resources necessary in any computer. And you may think that container is similar to a virtual computer, but that's not the case. A virtual computer replicates the hardware, that is the physical part, whereas the container executes on the existing hardware and uses the kernel functions of the host operation system. If you look at the diagram, that's a virtual computer where you have the operating system, you've got the hardware, the infrastructure, the operating system, all that is emulated by the virtual computer. And on top, you have the binaries, the libraries, and everything necessary in our application. However, Docker generates a layer that communicates directly with the host of the operating system. That layer, in general, it's Linux, and it provides APIs that can allow us to execute a container, not only in Linux, but also on Windows. And thus, the container can include only the app, the library, everything you may need, but not virtualization of the operating system or Java. It's far more efficient. It's using less memory and disk space, so it's easier to execute a container, and the app is ready in a shorter time. That's important. Now, if you want to execute a zip where binary is executed, a container has all the necessary resources for the app to be executed. For instance, in the case of an app created for Java, it has the runtime, JK, the Tomcat, the MSQL, environment, variables, libraries, binaries, everything. That's why we say that a container is a way of virtualizing an app to execute in an isolated and independent environment. It's as if you had a box where our web application is, but also the server, the data manager, the libraries, the environment, everything is there to be executed inside that box. Now, the register of our computer has no idea what's being executed, and nothing in the container can see the host. Of course, this can be configured, in fact. That is why I may have different containers with different distributions of Linux, because each container is including everything necessary for the application to be executed. It is executing it in a completely isolated environment because it needs nothing else. So I may have a container with SQL Server, another one with Tomcat, Java, whatever. Now, all this environment of executions, everything you need, is defined in what we call an image. And that image is declared in a text image generated by GeneXus, and so Docker is informed about all the resources that image will have. So a container is an instance of an image, and I can create as many containers as I may need. There is an analogy here with the IoT, because the image we may think is the class, and then you create an object. In this case, a container is an instance of the image. Now, what are the main benefits when you execute Docker containers? Well, to start with, I can execute our application in any computer, even if it's a Mac or a Linux or Windows. Everything is executed in a container, so I'll have to have Docker for Mac or Docker for Linux to create the container there. And so that container can be taken up to any execution stage. We've seen that every container includes everything necessary for the application to be executed. Now, if we want many instances of our application running at the same time, then we can we resort to to several containers? Yes, you can. A container may include everything necessary for the app, including the database. But the advantage of using containers is that you may have several instances of the same application under execution. The database is external to the containers, and it can be accessed by all of them. If every instance of the app had its own database, the users of the same app would see different data depending on the node they are accessing. Now, the recommendation is that the database is outside or even in another container, although most likely the best thing is that it's not, so that there is a physical container with all the power needed. Thus, all the nodes of the app will be accessing the same database, and if you need to scale up the application tomorrow, the only thing would be to have more containers with the same configuration having access to the same database. And if you want to delete them, there are containers. Now, there are tools for this. If the nodes exceed 80% of the load, they would automatically put in more nodes. Now, these are standard tools, and they work independently of whether the app was generated with GeneXus or with any other programming tool. Something else that containers are useful for is that if I want to try out an app, instead of installing lots of things and making my computer degrade as I install things, because even if I install and delete, there's always a registry in the trash. So what I can do is to have an image with the environment I want to install those tools and install them there in that container. On that basis, the app will continue working, there being no need for my physical computer to find out that I'm installing things there. Dockers are also good for an application being executed in a Docker container, and an app has a problem because it's consuming too much memory, or because there could be an infinite loop, or is consuming too many resources. That instance of the container won't affect other instances of the container being executed. So it won't happen as it happens now. If I've got everything installed in my computer with a web server and an application requiring a lot of resources of memory, that is going to affect the performance of the other apps. On the database, it would affect the latency of the other database. But if everything is being executed inside one single container, I won't have the problem that an application may cause problems to another application. Another important thing is that it's far more flexible. The development cycle, the test and deploy are easier. If something is tested in deployment, then the test will also be carried out in the same conditions. There may be something that changes. Production data are different from test data, but the conditions are far more similar than the ones we've got at present when we have to test something and move in from development to production. So the Docker technology is very beneficial. Now, what are more specific benefits to GeneXus developers? Well, it's possible to test that the application is running fine with Linux, even if we're doing it with Windows. So we can try a GeneXus web app in Linux, even if our operating system is Windows, and execute in Linux in real world. And you can also use ERR, or if a client wants to reproduce something, he can reproduce it in the same environment using a container. Something else that could be useful is that if I want to try out a technology that I don't know and I want to install things in my computer, I could look for the image I like, and it's useful, and install the software. So Docker's containers are useful for many things because everything is running in an isolated environment from the rest. Before moving on, are there any questions here? And I would like to tell you something that is very useful and that was probably going unnoticed, and it's that once you make a deployment in your development environment or test, the same image that you create is the image that you can try it out in the test, and if it works fine, that is sent to production. You needn't change anything there, and that is taking into advantage some of the functionalities that Rodolfo was mentioning, and that's the environmental variable. Most certainly, my app would be tested on a test database, and in production, it would have another database. Now, I could take the same container and say, well, when I upload it, according to the environment variables, to have access to the new database. That's something that we didn't have so far, or that you had to go into the web configure when you're sending it to production, or touch upon other files. That isn't necessary with this technology, with the change of variables, as he said. A question there? As regards the web config, I've got an application that perhaps with F5 it stopped working, mobile, and when I found out was that the web configure had exceeded 250K, and that was a limitation that was fixed with the change in the server, change in the registry. So I've got a question. Is it necessary that you include in the web config? I suppose it is, but I don't understand that very well. And the other thing is whether you can split that file so that it doesn't exceed the weight. And if there was any problem to upload it to the Docker, could you do with a GeneXus server? Or is it going to break down? And how do I do it in a Docker, to touch a registry so that it works out again? I don't understand that very well. Now, your first question, do we need everything that is in the web config? Well, yes. Because it's got everything that the KB has. When you make a deployment in the web config, you have all the endpoints of the REST services that you may have on your KB, but perhaps in the deployment you don't need all of them. So you would take away all that part, and you would add only the things that you need for that deployment in particular. So I would say that 90% of the cases, the web config of our deployment is going to be smaller than the one GeneXus works with. And there's a login on and many other facilities to prototype it. And so the other question, whether you can take it up to another file, yes, we're not using it. I had never heard about that problem, that the web config was too big. Well, the wiki has documented that. I would say it's difficult that this happens in a deployed environment, but if it does happen, well, you could do those things that you've done. Now, as how to modify it in a Docker, well, there are certain specific commands, and you didn't be an expert in Dockers, but, well, you should know that there is a Docker exec command where you can enter through a command line to the container once it's running, and using PowerShell or any other tool, command line, you could change the registry to continue running. And then after modifying it, that it's called commit. You can have an image with the modification. So whenever you have to do the same, so you needn't do the same whenever you need to make a change. Once you change the registry, you save it, and you use that to upload the rest. I suppose you've already done it. Going back to the previous presentation with Jenkins, I can activate it and get the container. Well, yes, because all this is done with the SA builds task, and you can program it. So all the build is run correctly, and it generates a Docker. Yeah, right. Yes. As an online Docker, you could have a task publishing to a registry, to the public network. I think there is a demo coming next about containers. Thank you. We tested it with docker.net, and it created an image of about 10 giga. Is that usual? Is that normal? Well, in the Windows world, it is. Images are perhaps too big, or much bigger than the Linux. In the traditional network.net, those are far bigger images. In your case, I would recommend going back to Netcore. It runs on Linux. Images are much smaller, and they work on Linux. And what about Store? Well, I don't know if Winstock can use window containers. I don't think so. Netcore and Java, yes. No, those are the two alternatives. Thank you. So for .NET, the only alternative for .NET is to move to .NET Core, where Amazon is reducing the size and adding functionalities. There was one to reduce the size of the necessary Windows image to run this app. So perhaps they get to Linux sizes. Thank you.
Vamos a ver ahora lo que sería.
We'll see now the deployment unit objects. This is interesting because very often we were asked that when the deployment of the application was being done, it could save all that deployment somewhere so that afterwards it can be repeated at another time. For this, we created the object deployment unit. Under this environment, you're going to see that there is a node called deployment unit. And when I open the application deployment tool by build application, by default, it's going to create a deployment unit. But I could create different deployment units to make my application, for example, separate in parts and say, in one deployment unit, I want to put only the website. In another one, I want to save the deployment of the REST services and so on. So it will allow me to save all the objects that would be part of the deployment. And as I can create the several deployment units, I could classify these and do the deployment separately for each thing. So I click right, I choose deploy application, and I can do the deployment only of this deployment unit without the need of doing the deployment of the whole application, like in the case when we had the build application. One thing we can ask is when we drag objects to a deployment unit in the window of the deploy application and then we modify those objects, the deployment will take into account the last changes I made to the objects, or whereas when I drag them, the state of the object freezes and the deploy is how the object was at the moment in which I dragged it. What is clear is that since we are doing a deploy in the deployment window of the application, there is a reference to the objects that are compiled because this is what is going to be taken to production. If in the window you added objects that were generated but that then are changed and are not generated, then it's going to use the ones that were generated previously. If you create a frozen version of the KB, the state of the object with regard to its edition is saved, but not the state of what is generated or compiled in the object. The way of saving what is generated or compiled is using a deployment unit in the window of deploy application. Let's see in GeneXus this concept we've seen about doing a deploy of an application. Here I have created a KB with a transaction to which I have applied the pattern with for web, and through the data property I have created a data provider and I've put information of countries. I execute the application and here I have the main, which is the home object, and the work with country. And these are the data I have programmed in the data provider, which are entered in the database. I want to do the deployment of this application. For this, I go to Build, Deploy Application. And here we see the window to do the deployment. I have two environments, one Java and one .NET. If I'm in Java, in order to do the deployment of the application, I have to drag here the main object of my application. In my case, the main object is a web panel. And now I have to choose a target. In order to do a deployment to an image of Docker, I need to create a Docker image from which there will be a container on which I can execute the application with all the necessary resources. And I need to have installed Docker for Windows. I have it already installed. And here I have some properties that I will be able to set. In my case, I didn't set anything. I left it by default. As you see, we are in a Java environment. Therefore, I could change so that the container is a window type, but I want to have a Java. And when I choose Docker image, I see some properties. For example, it's going to use a Tomcat 8. It has a name of who's going to maintain this, and where the web app is going to be inside the Tomcat, the name of the image. That is the name of the KB plus the name of the environment, GX15 Java environment. And I'm going to interrupt Rodolfo to tell you more about these properties. We suggested, I don't know whether you can read it, but here it says Tomcat 8.5J Real Pine. This is the image we use to package the application inside our container. You can change it and put another image for another application server even. So in this case, you also have to put where inside the container the resulting word is going to be copied. In this case, user Tomcat web app, etc., you can put web feed or whatever. So the path is obviously going to change. I also wanted to clarify that the deploy steps, the generation of the word in this case, are always the same independently of the target. And then there is an ulterior step, what is done with a target. In this case, create a Docker image so that it remains in the container. So, doing a deploy. When you do this, GeneXus is going to download whatever is necessary from the Docker site. It's going to execute certain Docker commands and obtain the necessary. In this case, it's obtaining the Tomcat, downloading it, and everything that is required to execute this save application. Let's wait some seconds. And here we see that the deployment is done successfully. This means that we made a deployment to a Docker image. In order to see the Docker images, we have to open a command window. So we execute, we have a command window, and I'm going to do the command that we had seen to see the Docker images. I use the Docker command, images, and here I see that it's created two images. One that is the one that was going to create from what it had told me, and here on the right hand side we have the name that is going to be assigned to the image, and also it created an image for the Tomcat 85 etc., Alpine. This is the image that has been created, but in order to execute the application based on this image, sorry, let me interrupt to show you one thing. Here we see two images. One is Tomcat, the one at the top, and the other one is the one created by GeneXus. If you see, one weighs 106 megas and the other one 114. I don't have 220 megas in use in my disk at that moment because our image, it's the 106 plus the difference to reach 114. So I'm not using 220 mega. Docker is intelligent enough to know that the image that we've generated is that from Tomcat plus other things without it. It's just that common. I have a question here. With regard to the Java version, since when is it compatible to work with Dockers? GeneXus 15 upgrade 8. Now, when we see there the Tomcat is a Docker that contains Tomcat. Yes, 8.5 in this case. That Tomcat, I bring it or get it predefined, or do you have it more or less already set? Well, it's what says up here. We are using an official image of Tomcat so that the people who want to deploy their applications in containers can base them on their official images. We download the image and add there the things of our application. And in the case of .NET, when we work with Internet Information Server, yes, we also have an image. They don't charge for this because the window that goes there is Windows Core or Service, I never remember which one, that does not have issues of license for the image. Maybe afterwards a provider can charge you for uploading it, but you can upload it in your own server. A container then, and in order to create it, I use the command docker run rm so that when the execution finishes, it is automatically erased and API for the port. So these are the ports that are going to be mapped, 999, etc. And the image is the following for the creation of the container, the one that you see here. Update cores, GeneXus 15. Java environment. The name of the image is a bit too long. So here are the instances for the image. I'm going to open another command window. And in this other window, I'm going to see whether the container appears with instances. So I'm going to give the command docker ps, and here I see that this container has been created. This is where my application will be able to execute. Therefore, the application will execute in the port 999, in port 999, and here we are going to write what will be the URL of the application. So it will be localhost 999 course update, and this is the name I gave the application in GeneXus. When I created it, I put in GeneXus app course. So this is what it's going to be, serverless, and then the name corresponding to the Java package, which we have here in GeneXus. You see the Java package name. And finally, the name of the object that I want to be executed, which is the home object. So here we have the application running inside the container in port 999. Just one comment. This was done before version 16 was released, but now it's in the root of the application. The name of the application remains in the root of the containers. That's the difference. Here we have the data already in the database that is running the BMS inside the container with that tomcat in the direction we saw. We can see whether it's actually running Linux, because we are executing a tomcat that is installed in a Docker that is interacting with Linux operative system. So to show you that I'm actually executing in Linux, I'm going to try to execute the batch. For this, I'm going to do the command docker exec, and I'm going to make a reference to the Docker that has been created, and then fill the information as you see. Let's see if we are in Linux. We are going to do a CLS, because CLS is a command of DOS, and clear is the command to clean the screen in Linux. And here I could move to the bin folder and see the content, etc. So I'm actually inside a Linux. I'm going to leave, and we already have an instance that's running in port 999. So I could create another instance in a different port. For example, it could be creating another container, Docker run, but now I'm going to do it in port 9991. And what I'm going to do is open another window, but now this instance should be running in this port. And here we have a 999 and the other one 991, but they are both targeting the same database. So if I go here and change something of this instance, I go to the other one, I refresh, and you see that it's changed. So I have actually two applications that are being executed at the same time in two different containers, but they are having access to the same database. So in order to finish with this, I am going to see what are the containers that are running. You see that we have two containers, the one I created first and then the other one, and I'm going to kill these two containers because I don't want to continue using them. So kill 3D9, and now I have only one, and I'm going to do a kill of the second one. And now I don't have any container, but I still have the image of the update course and the image of Tomcat in order to be able to give an instance to the new containers. So we are going to close this command window. And since we are in GeneXus, we are going to see another concept that we had mentioned, the deployment unit. You see that in environment, I now have a deployment unit that by default is called deployment unit 1, and that was created automatically when I did the deploy. But of course, I can change the name of this. For example, if I wanted to say that I want to separate by units the various types of parts of an application, I would put here only the site or the website. And for example, I would like to create another deployment unit called services, where I could include all the REST services I have in my application that I want to have inside a deployment unit of services. So when I want it, I want to do the deployment of the website or the services independently. So if I right-click here, I can deploy the application, and this opens again this window. You see that I have here the deployment units. And finally, this allows me to save. If I go to local, for example, all this that has been assigned to a certain deployment unit, and that deployment unit can be deployed at any point I want. So I can set up all this structure for a deploy, but not do the deploy at the same moment, but save the structure in this deployment unit, and then with the right click, I deploy when I want. And on the one hand, I deploy the website, the services, or other parts in which I want to divide my application. Very good. Do you have further questions? Two questions. With the deployments, do you have anything similar to what you did in the build to have commands that are pre-built and post-built? No. In GeneXus, we don't have them, but in the scripts of MS Build that we have to do the deploy, we have extensibility points, the MS Build tasks, where you could execute things before and after each deployment. Is that in the wiki? Yes, it is. And if it's not, then we'll take note. Secondly, we have been using deployment units, but the properties will be the same when you change from deployment unit. Yes, we're working on that the properties are also saved in the deployment unit.